Today we're going to create a cut jig for a series of parts that will be incorporated into this westinghouse unit. We'll begin with cutting our basic jig block. First we have to create it. Control T gets us top view. Rectangle by 2 points. F3 for the plane. 6 inches by 6 inches. Align it. Control I gets us the isometric view. Hit escape to get rid of the command. Hit the padlock to get rid of that. Mouse over your sketch. Click on it. Drag it down. We now have our block. Save this. Next we want to create an assembly. I'm going to save this as a cut jig assembly. Drag my part in. Also drag in a part typical of what we're going to be cutting. I'll select this one. One inch offset from this side. .75-inch offset from this side. We aren't real fussy here. We just need to get a general location that leaves plenty of material around what we're going to be cutting. Okay, now we need to take this part and we need to drag it down 1/10 of an inch. Do not repair unsatisfied relationships and delete the same. Hit escape and get out of that command. Under features, you're going to find this subtract function. Accept the default. This is the target body. Left click it, hit enter. This is the tool to remove the volume. Left click it, hit enter, and finish. Escape gets you out of that command. As you can see, we now have a void there that is the equivalent of the part that we want to cut. However, we're not done. Right click on this, left click, edit, select this surface. Right mouse click drag, brings you into the radial menu. Let's try that again. As a matter of fact, it's just easier for the point of this video because I don't want to have to do things over. We'll just select add mode, hit that, drag these surfaces down 0.10, enter, and enter again, and we now have our surface to work on. We need to do an additional thing. Control T takes us to the top view. We need to put some threaded holes in this block because I'm going to use some button head 7/16 screws for the hold down of the part. Threaded holes, obviously. 7/16, 2-inch finite extent will take us through the part. F3 selects the plane again. Make sure your pick filter is set for what you want to do. It's the center point. Right click finishes, Control I again. And you can see that we now have our holes and we have our location points. So save this, close this window out now. Actually, there is one more thing we need to do, and this is an important step. Go back to the block. This block needs to be raised 1/10 of an inch because we want our XYZ 0 to be at the corner here. Since we know everything is 1/10 of an inch, type in 1/10, enter, and enter. Accept it. Save the part again. Close and return. Now, this part also needs to be realigned. So, hit it, drag it up into space, get out of that command. Let's do an assembly again. Okay, come on, darn you. Escape. If the command doesn't at first work, then just start over. That face, I hit the wrong face again, sorry about that. Hit the correct face, hit that face, we know we're aligned now. Escape takes us out of that command. We now have our jig with the part assembled on it correctly. Save as translated. We're going to save this as a parasolid file. Save this. Close this out. File open. Parasolid. We want to open this as a part. Now, open your CAMWorks toolbar, extract machinable features. Let's see what we have. We don't want this, that's already done in another operation. Delete. We do want that, and we want that. Empty the recycle bin. Generate operation plan. What do we have? Let's just find out. Generate tool paths. I don't want that. I want that. I do not want that. Now, I haven't played with CAMWorks long enough to be real conversant on how feature recognition works. My understanding is that you can set this up and that CAMWorks will learn what it is that you want it to do, and I can quickly set these things up so that I will recognize what I want done here in this particular type of part, and I won't have to fool with what I'm doing and deleting these tool paths. However, for now, we're going to do it this way. Empty the recycle bin again. Okay, I want to edit this part, this definition. I want to use the same end mill for this as I'm using for the cavity. So I'm going to go to the tool crib. I'm going to select the part, or the end mill that's being used for the cavity. Yes. There are a couple of other things I want to do while I am here. On the contour, I want to get out of percentage and I want to use an actual depth. 0.2 will work, and 0.2 will work. This will automatically be limited by the bottom of the part, so I don't have to worry about the idea that at this time the cut depth is deeper than the part itself is. I want next to go to feature options, and I want a spiral entry. I do not want a straight plunge on this. The default here is fine. OK, generates my toolpath. I have a toolpath. Edit definition. The tool is fine here. So what we're going to be selecting again is the contour. Point 2. Point 2. Feature options. I want a spiral entry again. Accept the defaults. OK. And I now have a toolpath for that. So let us just see what we've ended up with. Simulate the toolpath. And here we are. We now have a finished part on a jig that was machined just for this particular family of parts. And you can see how quick and easy it is to do these types of things working within the same program. Thank you for your time today.